This is our wrap-up segment. So, Jeff Taft, thank you very much for both leading off and for closing. We greatly appreciate it. And without further ado, Jeff.
All right. Well, thank you so much. I'm going to try to draw out a couple of points that have come up in the conversation, maybe connect a few dots, and I'm going to return to something that I talked about a little bit on Tuesday, which has to do with understanding how you decide what kinds of things go into a platform, what are core, and especially with reference to storage. I'm going to try to connect a few dots on that. So I will say, based on all the things we heard, the word platform is clearly still in the running for Utility Word of the Year. We heard it on a lot of different scales, from large scale like the whole grid to as small as what Epri talked about, using an individual utility meter as a platform for computing and analytics. So as we talked about, it's a very useful and flexible concept. And I think on the first day even, you talked about the consensus that communications is one of those things that in the distribution system is a key layer that would be core for the grid thought of as a platform. And I'm going to talk about that and maybe expand on that just a little bit. So, and I agree with that view. It used to be the case that we had a lot of siloed communication systems, and I've worked with utilities that had as many as 8 different communication systems they were using to operate their distribution system, because they were largely attached to individual applications. And so that was a set of vertical silos. And that applied to the sensing devices that were part of that as well. So AMI is an example of that would be entirely siloed and would have its own communications, the sensors being the meters and the applications on top being the meter data management and billing and so on. But there were a lot of other ones as well. So what I'd like to suggest is that when you think about communications as being a part of the core platform that is the distribution grid, and being one of those layers, that you add to that the idea that sensing and measurement capability is part of that core as well. Now, for distribution systems in the past, say our 20th century distribution systems, we didn't have a lot of sensing and measurement. And it wasn't really too necessary, because for those systems, except for protection functions, nothing happened very fast, not much faster than about 5 minutes. So we had, human operators, and if you ever talked to one of those operators, they would say something like, well, nothing happens on my distribution system unless I either make it happen or authorize it to happen. So it's very much human in the loop. But as the dynamics moves to faster and faster scales, which happens when we start to have a lot of new functions and distributed energy resources, that's not sustainable. So we have the need for automation. And as soon as we start to have automation in the grid, we have the need for sensing to support those automatic activities. So thinking about this, we need to have, and I'm going to introduce a new terminology here. I know you've been bombarded with new words for the last several days. I'm going to give you one more phrase. The utilities to think about in their modernization plans developing an observability strategy for their grids. Observability is a term that comes from control engineering. It really means having enough information to know what's going on in your system on a common sense basis. We can get very technical about it, but what it comes down to is, how many different kinds of sensors should I have? How many should there be, and where should they be, in order for me to be well enough informed about my distribution grid so that I can do all the things I need to do going forward? And that includes in an automatic sense. So when you think about distribution automation, it includes adding sensing and measurement capability, and that should be combined with communications to be thought of as that infrastructure layer. So it's not just communications, it's sensing and communications. And that can be done in a very effective fashion, and it changes the way perhaps you think about the business case, the operational model, and so on, for the grid as being thought of as a platform. So that's one point I would say that's important to think about. When they do that observability strategy and think about the communications then, you can think about allowing sufficient headroom for not only the present set of planned capabilities, but for the future. Because we talked about future proofing, and the question was a little bit, so how do you do that? Well, we know a lot about how to do that with things like communication networks, because we've learned about it from other industries, but there are some aspects of, and I'm going to use some more ility words here, modularity and scalability, optionality, the ability to support different kinds of capabilities going forward, and the ability to support proportional deployment meaning you build out what you need when you need it and don't try to do it all in one giant leap. Those are kinds of things you would look at to help you a little bit with future proofing, as well as looking at that layering effect that I talked about, where upper layers are isolated from changes in lower layers by the middle layer. You would look for that kind of capability to help you, so that if you have to make a change in one layer, it doesn't ripple through everything else. And if you do the sensing and communication layer well, you can actually reduce the cost of integration of all these various applications that need access to all that data that comes from the grid. So there are ways to get at that future proofing that are essentially architectural in nature, and they require that you kind of think about regrouping things from the traditional way they have been done in the past a little bit, and take those silos and split them up into layers and so on. So that's one thing I think is important to think about. The next thing I want to talk about touches on a comment that I heard one of the people talk about but didn't dwell on very much. And I'm going to relate this to the idea of the use of storage at the distribution level in particular. The reason I'm going to do that is because we heard a lot about storage, but a lot of the things we heard had to do with supplying services to the bulk energy system. So a lot of those stacked values were things, regulation services and a lot. But there are things to think about at the distribution level. And to get at that, let me take a slight divergence here. The thing that I heard somebody say was in regard to conservation voltage reduction. And the comment was, this is a thing that you could do that didn't require any special actions or behavior changes on the part of the consumer. And I think that that's really an important thing to think about here, because a lot of the things that people talk about doing with the grid constitute exporting the constraints of the grid onto the consumer. So philosophically, we built the grid to serve consumers, and to some extent, when we ask the consumers to change their behavior because of something that goes on in the grid, we're kind of saying, well, maybe instead of the grid fully serving consumers now, to some extent, we want the consumers to serve the grid too. And you could argue that, well, we're doing that for the good of everybody, okay, but maybe in fact there's a better way. In many complex systems, and even some simple systems, we have this thing that we think of as a buffer. In communication networks, because the bit stream that's coming into the communication network might not be even, it might not be constant, we have these things called jitter buffers, and they sort of deal with the fact that the incoming stuff is not an even flow, and they even it out for the rest of the network. In logistics systems, we have buffers. They're called warehouses. In gas systems and water systems, we have buffers. They're called storage tanks. You can see this time and again. One of the places we don't have that kind of buffering is in distribution systems. We don't have any sort of sponginess or springiness that allows us to deal with the fact that there might be volatility coming from either the bulk system or from the edge connected devices. And yet we could, because now we have technologies that you heard a lot about today in terms of storage that could be used at the distribution level to give it a certain amount of sponginess, a certain amount of buffering capability that would have a variety of benefits in operating that platform. Dealing with the volatilities that come from either direction is going to become increasingly important. And in the Minster project, you heard an example of that. They talked about using storage to deal with the fact that sometimes the transmission lines are down. Think of that as a volatility coming from the bulk system, and they were using that as the kind of buffer to help them through that. In the other direction, when you have a lot of things connected at the edge that are doing things that you can't deal with directly, they may be, solar and so on, it creates volatilities on various scales. And we don't, again, have a way to sort of buffer that coming in that direction, and that can be passed through to the bulk system. In the California ISO, they're actually becoming concerned about volatility from what they call the edge, meaning distribution, being exported into the bulk energy system, and looking for ways to help manage that. So if we thought about storage at the distribution level as being that kind of shock absorber, sponginess, springiness, we might see some different ways to think about it. Almost all the things you heard about storage today involve stacking of various values related to services that you could supply to the grid, mostly some services that you could supply to consumers. And I can tell you there are in the industry lists of these kinds of services and value streams from storage that have as many as 50, that's 50 elements in them that people have thought about. Because storage, as we're looking at it now, is a very flexible kind of component. And the quadrennial energy review that the Department of Energy did, it talks about storage that's what they called fast bilateral storage. That means energy can go into it and out of it very quickly in the same form, combined with power electronics, which is the nature of the interface you need, and advanced control, as becoming a general purpose grid element as basic as a power transformer or a circuit breaker. We're not quite there yet, but we're clearly moving in that direction. We don't always think of it that way. We tend to think of it now in terms of value stacking and benefit cost analysis and bidding services into wholesale markets and all that sort of thing on the one hand, and as resilience for consumers on the other hand. But maybe we should think about this as storage becomes part of the core infrastructure at the distribution level, meaning that you would expect to see that handled perhaps by the distribution utilities, just like they handle power transformers and circuit breakers to make that system work reliably. A problem with this, though, is that in a lot of places, that would be judged to be handling commodity energy transactions. So, for example, if you thought, well, I'm charging up the battery and then I'm using that charge to handle some volatilities, someone might say, that's energy for resale. And that can be an obstacle. But what I would suggest is that there are a collection of capabilities that storage can supply that improve the resilience of the distribution system, allow us to sort out these volatilities, and I can even show arguments for how they help with cybersecurity. That would be core functions that should not be thought of as those kinds of commodity energy transactions. But in order to do that, it would be necessary to make it possible for the distribution utilities to use the storage in that way. I think that the functions can be delimited well, so that's done properly. But we don't really have the regime to do that today, and it's difficult for distribution companies to think about it in that manner. So that would have an impact on regulatory and financial treatments, as well as thinking about the technical issues of how to do that and how that would scale and so on. And I don't believe that that would necessarily have to interfere in any way with the other kinds of applications of storage. We've talked about how flexible storage is. So overall, I would say, you've gotten a good view about the idea of platform and how platform applies on multiple scales across all these things. We heard that. I was listening to some of the presentations when I wasn't here. I would hear people say the word platform so quickly and automatically they almost skated right past it. And I'm sure you picked up on that, but it's a core concept that's going to occur over and over again. You're going to see multiple platforms. I think the most important one to think about in general, though, is the grid as being a platform. And whether it's a platform for electricity delivery or a platform for energy transactions, still that platform concept applies, and it can change the way that you would think about what would we view as being core infrastructure and what would we view as being siloed applications or things at the edge. And I think that's probably a really important thing to think about going forward. We're seeing that kind of consideration being thought out in other jurisdictions. And I can tell you that in Hawaii, the Hawaii Public Utilities Commission issued a guidance in January about how the utilities there should consider their grid modernization planning. And one of the things that they did was they very strongly guided the utilities to think about the communications and sensing as being core infrastructure. So, and I think that's an appropriate way to deal with some of these things. So overall, I think that's part of what you have to think about as you go forward in all of this is what is core infrastructure? Where do these things fit in? You've heard a lot of technology here. You've heard a lot about platforms, but the platform concept can help you sort out what fits where. So let me stop there and see if you have some questions.
Jeff, thank you very much. Really wonderful set of points that we can take with us between phases 2 and 3. If I could just, I don't know that I have a question, but maybe we could engage in some dialogue here. But just an observation, regardless of the sauce that makes up the platform, I think what has probably been, for at least for me, I won't speak for everybody else, most important is within this phase is just sort of a reveal from at least a commissioner policy maker perspective of some of the very necessary ingredients that are somewhat agreed upon, that go into the grid that would then yield the customer applications that we're trying to get to. And if you recall, this all begins and ends with the customer and trying to create a better future for the customer. And of course, one of the justifications for Power Forward, this concept of enhancing the customer electricity experience. And so I think this concept of platform has been a wonderful technical conversation starter for us, and the various core elements of the platform. We now have to connect the dots between what we believe to be some of these core elements, and then get into what is our very typical role of figuring out, okay, who and what we will allow cost recovery for, and how do you create the marketplace to yield these wonderful potential consumer applications. And so I would have said that, regardless of the points that you made. But I think that the points that you made sort of outside of, possibly the technical piece associated with storage, which we have to keep in mind going forward, I think the technical points that you made sort of coincide with that conceptually.
My undergraduate education is from here in Ohio, as you know. And in my first term as a freshman engineering student, all of the engineering professors, of course, felt obligated to give us a definition of engineering. A lot of those definitions were focused around how you do it and the kind of things you work on. But the one that stuck with me was the professor who said, engineering is the conversion of natural resources to the benefit of humanity. Nothing about how you do it or any of that kind of stuff. And the reason that stuck with me is because, we do that stuff for people. And you have the focus on consumers from the very beginning. And that's why I talked about, the idea of, are we exporting constraints of the grid onto the consumers, and are there ways to do that that don't impact them? I think that's an important issue to think about that's very much in line with what you just said about it starts and ends with the consumer.
Okay, very good. Questions for Jeff or comments? Anybody? Yep. Thank you very much. Tom, Beth?
I just think, once again, we've told you this before, that you have such a way of crystallizing some of the points that I think we really need to continue to think about and ponder and discuss among ourselves. And I just really appreciate how you can so easily do that. So thank you.
It looks easy. I spent a lot of time on these things to get to the point of making it sound easy. It's not that easy.
Jeff, thank you very much. Thanks to you. Thanks to all of our panelists that participated in Phase 2. I see John McDonald still here, hanging out with us till the very end. John, thanks to you. Chris Villarreal, who sort of facilitated the start of Day 3, thanks to you as well. And thanks to all of our panelists for your participation. I think what's probably evident from all of you in the audience is that we are learning as you present. I've said this quite a few times about Power Forward. This is not the type of proceeding where we have the definitive end state of the marketplace charted out in our brains, and this is just we are just having you come in and talk. So it appears that we are doing this organically. We are doing this very, very organically. And your help, your thoughts, your education, everything that you do is extraordinarily important to the information that we retain and what it will end up being, what we hope is the great future for electricity consumers in the state of Ohio. So thanks to a round of applause for all of our panelists. Thank you so much. I would, of course, be remiss if I did not thank Vice Chair Beth Trombold for her leadership again with developing Power Forward Phase 2. Christina Schaefer, who continues to make me look good because I promoted her on a day-to-day basis. So thank you, Christina, for all of your efforts. I would also single out Kristen Klingen, Commissioner Trombold's aide. All of this high-level thought, I come into a meeting with like Beth, Christina, and Kristen and just like spew out high-level thought and run away. And someone actually has to like put pen to paper and execute and work hard. And so Kristen is one of those individuals that's really working hard at this. So Kristen, thank you very much. Okay. Let me just say this about Phase 3. I think there's some recognition up here. This has been Phase 1 and 2 have been wonderfully educative. I think there's an acknowledgement that we need to take a large leap between Phase 2 and Phase 3. Creating the appropriate marketplace, which will undoubtedly involve what we typically do here, which is regulation, rate making, cost recovery. This is now the true challenge, and they are challenges that you see typically in the headlines associated with other states' grid modernization endeavors. We want to make sure that when we head into Phase 3, we have developed a game plan that will truly be, again, educative for us in the marketplace that we're trying to develop here. So I say all that to say we're going to take a bit of a longer pause between Phase 2 and Phase 3 than was between Phase 1 and Phase 2. We will announce the dates of Phase 3 in short order, but the five of us need to really do our homework now. And so, again, these first two phases have been tremendously educational, and now we're going to take our core competency, and we're going to take what we've learned in Phase 1 and Phase 2 to try and intelligibly chart out what Phase 3 will look like. So look for those. Look for the announcement of when Phase 3 will take place here in short order. But don't be surprised if there's a bit of a longer pause between Phase 2 and Phase 3. Thank you very much to everybody for your attendance. Thanks to everybody for tuning in at home, and we will see you at Phase 3.